In this lesson, we will learn about the parts of polynomials. In particular, we'll learn about the terms of a polynomial, factors of a term, and coefficients. The parts of a polynomial that are added together are called the terms of the polynomial. So notice in this polynomial here that this would be called a term, this would be a term, and this would be a term, because notice that all of these three objects are being added together. Okay? Each term, each one of these, is either going to be a constant term, which is called a number, or a variable term, which contains a product of one or more variables with whole number exponents. Okay, so this would be a constant term, okay, since it only contains a number, whereas these would be called variable terms because they contain the variable x. Terms may have factors that are numbers, variables, or combinations of both. To identify the terms of the polynomial 4x to the power 3 plus 2x minus 9, we first rewrite the subtraction as addition, like we've done here. So we started with this polynomial 4x to the power 3 plus 2x minus 9, and we just changed the subtraction to addition, because what we said before is that terms are those things in a polynomial that are added together. So now, since we have nothing but addition, this would be a term, this would be a term here, and this would be a term here. Now, the variable terms in the polynomial, they can be broken down into a coefficient and a variable part. Okay, so for example, let's take this variable term here. It has a coefficient, or a constant part, and a variable part. Okay? For the second term, 2x, 2 is the coefficient, and x is the variable part. So the coefficient is always the number being multiplied by the variable part. The degree of a polynomial in one variable is the greatest power of the variable. So for this polynomial that we see here, the degree is 3, because if you look at the highest power of our variable, the highest power is 3. Because this is x to the power 3, this is x to the power 1, this here would be x to the power 0. So since 3 is the highest, is the greatest power of the variable, I would say that this polynomial has a degree of 3. Notice that the variable terms, so this term and this term, they have common factors. You have to remember what a factor is. Like, for example, let's say that I have the numbers 12 and 16. Notice that they both have common factors of 4, because 4 divides both of those numbers evenly. So like I said, if I have the numbers 16 and 12, they have common factors of 4 because they divide both of those numbers evenly. I can express 12 as 4 times 3, and I can express 16 as 4 times 4. Now here, if I'm looking at these variable terms, notice that I just have objects being multiplied together. I have a 4 times an x times an x times an x 3 times. Here I have a 2 multiplied by an x. So notice that the variable terms have the common factors of 2, since 2 goes into both of these factors, or divides both of these factors. X also divides both of these factors, but there are no common factors greater than 1 for all three terms, because the only numbers that divide -9 are 1, 3, and 9. Okay? But notice that these two variable terms do not have factors of 3 or 9. So the greatest common factor of all three of these, okay, would be 1. Okay, you can also have a polynomial that has a variable other than x. Okay, for example, here I have a polynomial that has q as its variable. Now the variable terms in this polynomial would be 9q and -3 squared. Okay, these are the variable terms because these are the terms that actually contain my variable q. The constant term, or the term without a variable in it, is 6, and the degree of this polynomial is 2 because this is the highest power of the variable in the entire polynomial. This term here has a power of 1, this term here has a power of 0, and this term here has a power of 2, the greatest of which is 2, so the degree of the polynomial is 2. Okay, so one way that we can write a polynomial in is called standard form, and what it allows us to do is it allows us to easily identify the characteristics of and compare different polynomials. Polynomials in one variable are written in standard form when the terms are in order from greatest degree to least degree. You're going to see examples of this. Standard form also makes it easy to compare the leading coefficients of two polynomials, or the coefficients of their first terms. So let's consider this polynomial here. Okay? It is not written in standard form. So I have 16y plus 2y to the power 4 plus 11 minus 3y squared. Now the polynomial has four different terms, four different objects being added together. Okay, if I change the subtraction to addition. The terms and their degrees are 16y has a degree of 1 because there's basically an implied power of 1 here. 2y to the fourth power has a degree of 4, 11 has a degree of 0, and negative 3y squared has a degree of 2. The term with the highest degree is 2y to the power 4, so what we say is that the polynomial has a degree of 4, since this is the highest power. Now in standard form, remember, I write the powers of the variable in descending order. Okay, so notice that my term here, 2y to the power 4th, has the highest degree of all of these terms. So I put it first, as I did here. Next, notice the next highest degree is squared, since I have negative 3y squared, so this one would come here. The next highest degree is 1, so I put this 16y next, followed by the next highest degree, which is y to the power 0, which is implied here, and I'd put this last constant term here. So notice it's easy to see now that what the leading coefficient of this polynomial is. It's 2. Here's the coefficient of my variable term, and it's 2. The degree of this polynomial being once again 4. Okay, so polynomials often contain letters other than the variables that can take specific values depending on our situation that we're dealing with. These values are often called parameters. Okay, so let's say that I have this this expression here. My variable would be x, and a and b are called parameters. The parameters, let's say I give the parameter a value of 50 and b a value of 100. Alright, this turns my polynomial into 50 times x plus 100 once I substitute those values of a and b into my polynomial. This might represent, maybe, the total cost of a gym that has a monthly cost of $50 and a membership fee of $100. Here's another example of a polynomial that has parameters in it. This is called a quadratic polynomial because it has the highest degree of 2. Okay? It's a polynomial in the variable t for time. Okay, so this is the variable. The rest of these are parameters. Okay, the only variable in here is t, which stands for time. The rest of these are called parameters. Okay. Now this entire polynomial represents the height of some projectile launched upward in the presence of gravity. Okay, so you can think of this maybe as representing the height of a baseball, of a bullet, of anything that's being thrown. Okay, so the parameters a, v naught, and h naught represent the acceleration caused by gravity. That's what this represents. This is the acceleration caused by gravity. Okay, since this is a parameter, it could change depending on what planet we're standing on or our elevation here on Earth. Okay, this parameter here, v naught, represents the initial upward velocity of our object being thrown, and this parameter here, h naught, stands for the initial height. Once I know the parameters for a given situation, I can find the heights for different values of the variable t, because the only thing that will be left that we don't know is this variable t. So let's suppose that I have an air model rocket, compressed air model rocket, and it's launched straight into the air from a platform 3 feet above the ground at an initial upward velocity of 350 feet per second. Okay, so the height of this rocket in feet, t seconds after it's been launched, is modeled by this polynomial here. Okay, so what we're going to do in this example is we're going to interpret each term in this polynomial, and then we're going to use unit analysis to show that how the value of the polynomial is a distance. Actually comes out to be a distance in feet. Alright, so first thing we do, let's identify the terms in this polynomial. Remember, the terms are the things that are being added together. So notice that here's a term here, being added to another term here, being added to another term here. Once again, this is a variable term, this is a variable term, this is a constant term. Now, the term negative 16 times t squared depends on the acceleration of gravity times the square of the time in seconds after the rocket is launched. Okay. The term 350t is the initial upward velocity times the time in seconds after the rocket is launched. The term 3 is the height in feet from which the rocket is launched. Those are the values of our parameters. Okay, to use unit analysis, first we write the polynomial with its units in, and then we're going to divide out any common units that there may be. So first, notice that we have negative 16 times feet per second squared because this represents an acceleration. Okay, so the units of acceleration in this case are feet per second squared times time, which has units of seconds. So we abbreviate this unit of seconds with the letter s. Okay, so this unit here, or this variable here, t, has units of seconds. So I write seconds. Okay, and over here I have plus 350 feet per second because that's a velocity. 350 represents a velocity here. So in our case, this is feet per second. Okay, times once again time, which units are second, plus 3 feet. Now that I have all my units for my polynomial, I can see which ones cancel out rather easily. Alright, so notice once I distribute this 2 inside to the t and the s, I get t squared times this expression here. Notice that the s squareds will cancel out, so the only thing I'm left with is feet, as seen here. Alright, now here, inside the parentheses, I'm left with seconds in the numerator, seconds in the denominator once I multiply these fractions here through. Alright, so notice that the seconds will cancel out, and I'm left only with feet. And the last term here, the constant term, only had feet as its unit since that was the initial height above the ground. So notice here I'm adding feet, plus feet, plus feet, so my result will be, of course, feet. So in conclusion, what I can say is that this polynomial is going to give me a height in feet. Okay, so in this lesson, the question that we addressed is, what parts of a polynomial represent the terms, factors, and coefficients? Remember, the terms of the polynomial are the parts that are being added together. A polynomial may contain constant terms and variable terms. For variable terms, the coefficient is the number multiplied by the variable part of the term. For example, for the term 4x squared, maybe the coefficient would be 4, the variable part would be x squared, and the degree of that term would be 2. Each number or variable multiplied in a variable term is called a factor of the term. So for example, let's say once again I have the term 4x squared. Okay, one factor of 4x squared would be 2. Okay, because 2 divides 4x squared. Also notice that 4 is a factor of 4x squared. 4x is a factor of 4x squared because I can write 4x squared as 4x times x. X is a factor of 4x squared, and so is x squared. X squared is also a factor of 4x squared. So you can see how I have multiple factors, just like I would if I were dealing with numbers. So this is the essential question that we addressed in this lesson. Be prepared to discuss the reflection questions in class.